Our next example involves the fraction of tangent x minus x over x cubed. We always try direct substitution first, and tangent of 0 is 0 minus 0 over 0 is a 0 over 0 form, so we can apply L'Hopital's rule, taking the limit to equal the derivative of the top. Derivative of tangent is secant squared. Derivative of x is 1. And the derivative of the bottom, using the power rule, 3x squared. Now we can apply direct substitution again. The secant of 0 is 1. Recall that secant is related to the cosine. Cosine function is like this. Secant function looks like that. So the secant of 0 is 1. We have 1 squared minus 1 divided by 3 times 0 squared, which is, again, 0 over 0. So we can apply L'Hopital's rule again. Now, don't forget, this is a power rule because secant squared of x is the same as writing the secant of x squared. So the derivative is a chain rule. 2, inside stuff stays inside to the first power, times the inside derivative, which is the secant of x, times the tangent of x. The derivative of negative 1 is 0, divided by a 6x. Trying direct substitution again yields 2 times 1 times 1 times 0 divided by 0 is 0 over 0. This is indeterminate, so we can apply L'Hopital's rule again. Noticing that secant times secant is secant squared. We just took the derivative of secant squared, and it is 2 secant squared x tangent x. But then we have to apply the product rule. So what we're dealing with is 2 times the derivative of the first times the second plus, we have the 2 that carries down, derivative of the first times, derivative of the second times the first. On the bottom, it's just the derivative of 6x, which is 6. Drawing direct substitution, we notice that anything that has a tangent in it is going to go to 0. So all that's going to go to 0. And we're left with 2 times 1 squared times 1 squared divided by 6 is 2/6, which is 1/3.